We're going to take a look at another way to approach these second-order differential equations with constant coefficients that are non-homogeneous. So we're going to be looking at this method that's called variation of parameters. Now, variation of parameters is more difficult, it's also more taxing, but sometimes we can't make an adequate guess for the solution to use the undetermined coefficients method. So if it's too difficult, then we can go through and use this plug and chug method to kind of beat it up with this variation of parameters. So as you can see, there's a lot of formulas and there's some integration going on, but it's more robotic than anything. So when you guys are doing your homework and also your examination, if for some reason the method of undetermined coefficients doesn't work, then maybe what you want to try is the variation of parameters method. And so here's the process you're going to use. So first of all, you're going to find the complementary solution, not a surprise. And then you're going to find a particular solution, which is of this form. All right. And so we have this u1, y1, u2, y2. Now, y1 and y2 are going to be the parts of the complementary solution. All right. So in other words, yc, which is the complementary solution, is going to be equal to c1 y1 plus c2 y2. And from there, what we can do is we can go ahead and find these other components, the u1 and the u2. Now, u1 and u2 are found by these formulas. So the derivative of u1 and the derivative of u2 are equal to w1 over w, w2 over w. And w is going to be, all the w's are going to be determinants based on y1, y2, and then the function f of x. And f of x is what the non-homogeneous differential is equal to. All right. From there, we're going to integrate u1 and u2 with respect to x, and that'll give us the particular solution. So, as you can imagine, it's a pretty taxing ordeal, but it works. And especially if we're not able to use the undetermined coefficients method. All right, so each of these is going to be fairly lengthy, just be forewarned. So we're probably just going to have 4 videos for 4 problems, but it'll show you the techniques for each of these. All right, so let's start off with a fairly basic one, and so that way you understand why. So y double prime plus y is equal to sec x. We don't really have a guess for sec x other than a sec x. When we start finding derivatives of sec x, it starts becoming really ugly because we know the derivative of secant is secant tangent, and then from there we're going to have to use a product rule. So it might be easier to utilize another method, which is this variation of parameters method. We're still going to start by finding the complementary solution. Right? So that means that we set the auxiliary equation equal to 0. We can't factor it, but we can solve. So m squared is equal to -1, and that means that m is equal to plus or minus I. And we could even write that as 0 plus I. So in this case, a is 0, and b, which is the coefficient of I, is 1, and we can get our complementary solution. So yc is going to be equal to, it's a case 3, that's going to be equal to e to the 0x, c sub 1 cos of 1x plus c sub 2 sine of 1x. Or if we simplify that, yc is going to be equal to c1 cos x plus c2 sine x. All right, now we're going to hold on to this, but also of importance is that we use the complementary solution to deduce y1 and y2. y1 is cos x, it's the variable component of c1 term, and then the variable component of the c2 term is going to be sine x. And we need those because we need to build w. And then the other thing that we need is f of x, which is the secant of x. And so now we know that we can build W, W1, and W2. All right, so let's go ahead and find W. Now each time we do this, I'm going to go ahead and define these. So W is going to be equal to Y1, Y prime 1, Y2, Y prime 2. And that's going to be the determinant of cos x minus sine x for the derivative. Y2 is sine x, and we get cos x. All right. For those of you that have never evaluated a determinant before, it's really easy. Cross multiply down, so that's going to be cos square x minus cross multiply up, a negative sine square x. Fortunately for us, that just becomes 1. Okay. All right, so that's really nice that W is equal to 1. Now we need W1 and W2. W1 is going to be a little bit easier because we have a 0 up there. So it's 0 f of x, y2, y1, or y2, y prime 2. So that's 0 f at x, y2, y prime 2. And so that's going to be 0 sec x, sine x, cos x. So we're going to cross and cross. All right. And if we do that, that's going to give us 0 minus sine x sec x. All right, or in other words, just negative sine x sec x. All right, which isn't too terrible. It's not great, but it's not too terrible. And then finally for W2, that's going to be equal to y1, y prime 1, 0, and f of x. All right, and again, we're just getting that right up here from this formula. So y, y prime, 0, f of x. All right. Remember y1, excuse me, is cos of x. So we get cos x, negative sine x, 0, sec x. Multiply down, subtract, multiply up. And so we're going to get cos x sec x, and then minus 0. All right. Now remember that secant is the reciprocal of cosine. So ultimately this just winds up being 1, right? Because cos x times 1 over cos x is equal to 1. All right, so we like that a lot. All right, so up here we found W to be 1. We found W1 to be sine x sec x negative. Right? And then finally, we found W2 to be 1 as well. And now what we're going to do is we're just going to plug it back into this final formula to find YP. All right, so Y1 and then U prime 1, excuse me, is W1 over W. U prime 2 is W2 over W. So let's find those first. So U prime 1 is going to be W1 over W, which is going to be negative sine x sec x over 1, okay, which ultimately just turns into negative sine x sec x. And then U prime 2 is going to be W2 over W, which is going to be equal to 1 over 1. Usually that's 1. All right. Now we're going to throw that into the formula for YP. YP is going to be equal to, remember, Y1 integral U prime 1 dx plus Y2 U prime 2 dx integral. Or, now remember, Y1 was cos x all the way back up here. Y2 was sine x. Okay, so we get cos x times the integral of sine x sec x, it was a negative there, dx, plus Y2 which was sine x times the integral of 1 dx. All right. Now I'm going to factor that negative out. And then we have to integrate this sine secant. It's helpful to remember that secant is 1 over cos. So we can say sine x over cos x dx. And then this is just going to be x anyway. So we're going to get sine x times x. So getting close. To evaluate this integral, we're going to need a u substitution. Okay, so let's let u be equal to cos x. So u is cos x. The derivative is minus sine x dx. And that's good because we have a minus and a sine x and a dx. So we can replace all of that with du. And we can replace u with cos, or cos with u in this case. All right, so that's going to be equal to cos x integral 1 over u du. And notice that the negative, the sine, and the dx became du. All right, we still have that. I'm just going to call it x sine x. All right, almost done. We know antiderivative of natural log, or 1 over u, is going to be natural log of u. Right, so this is going to be equal to cos x ln absolute u plus x sine x. And remember, u was going to be the cosine of x, so we get cos x ln absolute cos x plus x sine x. And that's yp, mercifully. Finally, we need the entire solution, which is y of x is going to be equal to yp plus yc, which is going to be what we have above, cos x ln cos x plus x sine x. But then also, we have to remember the complementary solution. Remember, the complementary solution was just cos x plus sine x. And I think there were some C1s in there. So C1 cos x plus C2 sine x. So let me erase that. All right, so that should be it. Okay. If anybody wants to find the second derivative and the first derivative of that and then substitute it back in, be my guest. I will go with what we have here. All right, so we can see that unfortunately it's more rigorous. However, it's actually possible. All right, and unfortunately with the variation of parameters method, it might not be possible to find the solution. All right, so in subsequent videos, we're just going to take a look at maybe 3 more of these so I can show you the integration techniques as well as the algebraic techniques that sometimes occur when you're doing variation of parameters.